Everything with h's has to be removed from the numerator.
Without h, yes. Negative x squared with positive x squared, positive x with negative x. What is the second thing that has to happen for sure?
You have to factor out
Divide
the
by
h.
h.
Yes, I don't divide, but you're right. We can because it's only one term. I agree. But it's better to factor out as we have done so many times. But yes, I agree, we can divide, but term by term. Be very careful if you cross here and here, that's a 0. You're not supposed to simplify in a sum of terms or difference of terms. I'm not saying that that's what you said. I'm just making a remark. Good. So can anyone tell us what happens here?
2x plus h minus 1.
Excellent. Now, as expected, as we did this many times before, and now let me write one more step. If you drop the limit operator till you apply it, it's 0. Please, I'm begging you. So 2x plus h minus 1. Can anyone tell us what are we calculating? The limit of what? What is this? How do we call this?
The limit of
A polynomial. This is a polynomial. So how do we calculate the limit of a polynomial?
Plug it in.
Plug it in. So please plug it in and give me the answer.
2x minus
1.
That's it. This is our f prime of x. So please, if you'd like to upload this, I want to see the limit operator. Why does the limit operator disappear here? Because I applied it. I said when age approaches 0, the limit must be 2x minus 1. That's why the limit operator is no longer valid, no longer here, because it was applied to this expression. This function gives the instantaneous rate of change of the original function at any point x where the function is differentiable. So for example, now they're asking us for the last part, for part D, to find f prime of -2, to find f prime of 0. In other words, they're asking us to determine the rate of change. In other words, they're asking us to determine the slope of these little tangents that I drew here for you. Can anyone give us f prime of 2, of -2, and f prime of 0 and f prime of 1? So I can write them here. So what is the slope of the tangent line at -2?
I'm sorry, how did you get the 2x minus 1 again? I was still copying down.
Sure. Age approaches 0.
Oh, that makes sense. Thank you.
Thank you. See my props?
Would be -5.
Excellent. Next one.
Professor, are we putting in the each number for x, right?
Yes, please. Yes. That's what it is. F prime of x, f prime of 0.
Okay.
Exactly. Very good. So this is the slope of the tangent at x equals -1, or the instantaneous rate of change of the function at -2. So here,
-1.
good. And the last one?
+1.
Of course. Was this what you expected? Yes, I'm sure you did. This is much steeper negative than this one is. So this is -5, and this is -1. And as expected, this is positive, and it's 1. So the slope of this line here is 1, the slope here is -1, and the slope here is much steeper, -5, as expected.
Professor,
Yes?
can I please see the last page?
Yes?
Oh, yes, please. The bottom of the last page, I am missing the stuff in red.
Yeah, it's what we just did 10 minutes ago. We just plugged it in to find f of x plus h.
I just chase kids away from me like every 2 minutes.
That's
when I do
okay.
it, so every now and then, luckily they're in bed, so it's quiet now. But oh,
That's okay. No worries. Now, I would like us to, this is additional that I would like to do. Please determine, tell me which one you would like to determine the equation of the line for. Do you want to determine this equation of the tangent line? Do you want to determine this equation of this tangent line or the equation of this tangent line? You choose. Which one? At one? Yes?
can I see that red section real quick? I need one more thing.
It's
Hold
you plug x plus age in the function.
Oh, it's just for a generic difference quotient. It wasn't a specific formula. Okay, never mind.
Yes, it
That's
is for
right.
specific
I thought
formula.
you
It's
used-
this one. Of course, we are working
Oh.
on problem 11, and this is our function, of course. We are still working on the same function, yes. So that's why I have x squared minus x. So which of these three tangent lines you would like to determine the equation for again? At -2, at 0, or at 1?
Let's do at 1.
Let's do it at 1. Very good. So, to find the equation of the tangent line at x equals 1. Anyone reminds us what is the equation we have to use?
Is it y equals mx plus b?
Yes, but we don't have the y-intercept.
No, point slope.
Point slope form. Okay, so can anyone give us the point we are calculating? We determine the tangent line
1,
for?
0.
Very good. So the point is 1, 0. So the point is 1, 0. Good. Can anyone give us the slope of the tangent line at 1?
Real quick, what it says to find, what are those 3 letters? The
Oh, I'm
equation?
sorry. THE. Equation.
oh.
Sorry.
Miss Dean,
Say it again.
what do you want us to upload? This page or the other one?
What we just finished.
Alright, so this, right?
Yeah, just that.
Okay.
So can
Oh,
anyone...
so upload it now.
Good, yes. Can anyone give us the slope of the tangent line at 1?
1.
Of course. We just determined it. Good. Excellent. So then the final is y equals x minus 1.
Wait, do you want us to upload the part that we're looking up now or the red part that we just did?
The part that we just did.
The red part?
Yeah, I just wanted to see the limits.
The whole thing?
Yeah, I just wanted to see that no one will drop the limit operator till the end. That's the whole purpose on that.
Okay. Wait, can you go back up for a second? Sorry.
If you've dropped the limit operator on a test, I can't give any credit. If you do not follow those steps with a limit operator, I can't give credit. Full credit, I mean. Okay, so this is the equation of the tangent. The equation of the tangent to the graph at 1. Okay, moving on. Good. Okay, so let's see an application of all this discussion that we are just having. So we know how to determine f prime with the limit as age approaches 0 of the difference quotient. So please remember how we determine the derivative of a function. And then I would like to look at an example like this. Here it is. Okay, 35. Draw a graph that has a horizontal tangent lines, that has horizontal tangent lines at x equals 2 and x equals 5, and is continuous, but not differentiable at x equals 3. Not differentiable at x equals 3, but continuous. Okay. Okay, this will anticipate something very important in this class that you will see very soon. We're going to use this table in which we are going to put f prime as the first row. Well, of course, x has to be the first one for the domain. And then f of x. So this is the derivative, and this is the function. We are told horizontal tangent at x equals 2 and x equals 5. Okay, so let's analyze this for a moment. So if a function has a horizontal tangent, so this is not horizontal, this is not horizontal, this is not horizontal. This is horizontal tangent. Do you notice what happens here? What kind of point is this? If the function has a horizontal tangent. Don't say anything just yet. It could also be this way.
Would it be at the vertex?
Very good. So it's vertex only if it's quadratic. Perfect. So we're going to say, so I lost somebody. It's coming back. So here's a maximum or a minimum. So by definition, when the slope of the tangent is 0, we are talking about a max or a min unless is something like this. Okay, careful. So this is possible, so for the tangent to be horizontal and not have a max or a min. We will discuss the conditions later. Okay? When these happen. Okay. So for a horizontal tangent, I know all these three cases have the slope 0. I'm told 2 and 5. So this is 2. Something happens at 3 and also 5. So at 2, it has a horizontal tangent. The derivative, which is the slope of the tangent, is 0. Done. Horizontal tangent at 5, which means 0. Done. What's 0? The derivative, which is the slope of the tangent. So these two are identical. The rate of change at 2 is 0. The rate of change at 5 is 0. I don't know, max min, or this, but I'm told horizontal tangent. That's all I need to know. It's not differentiable at 3. The derivative does not exist at 3. I don't have anything to write. It does not exist. If you don't like that, just write DNE. Okay? Not differentiable at x equals 3 means the derivative does not exist at 3. Done. And the function is continuous. I make myself a note. Continuous function. We have infinitely many solutions here. We are only asked to graph an example in which the function has a horizontal tangent at 2. It's continuous everywhere, but does not have a derivative at 3. And it has a horizontal tangent at 5. Okay, here is my example. 1, 2, 3, 4, 5. I only need 2, 3, and 5. Horizontal tangent at 2 and 5, and not differentiable at 3. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Let's see. Do I have a horizontal tangent at 2? Yes. Do I have a horizontal tangent at 5? Yes. Is the function differentiable at 3? No, because I drew a vertical tangent. If it has a vertical tangent, the function is not differentiable at 3. And this is my example. You can be creative and do whatever else you want. You can make it a corner. You can make it a corner or a cusp, and it goes up, and it has a horizontal tangent at 5. You can do whatever you want. This is just one example. And I will end by only saying that we also have a notation. It's called Leibniz notation. So f prime of x can be denoted also by the derivative of y with respect to x, dx over dy. So everything was finished. 1.3 and 1.4 is due in my lab math for Monday, plus written homework. So this is done.